Assalamualaikum warahmatullahi wabarakatuh. I bid to my fellow panels. Before I start my FYP demonstration, I will introduce myself. My name is Muhammad Shahmi Ben Zainon and my FYP title is Electrical Generation by using a wind turbine. In this video, it will have three parts. First part is 3D design, second part is CFD simulation, and the last part is Matlab. So we will go to our first part. In this part, I propose three wind turbine design that have same size with at radius 0.965 and has same shape, but the only difference is just at the number of vents around it. So let's take a look at our designs. So this is my first design. There is no vent around it, just a frame. This is my second design. It has four vents. And lastly, wind turbine with 5 vents. As for your information, when there is a wind, this turbine will rotate like this in one single axis. So after we finish design the turbine, we will go to our second part, which is CFD simulation. This is my second part, which is CFD simulation. I use Autodesk Flow Design to run my simulation. Before the simulation start, I usually will do a orientation of the object. I will rotate the object at axis for about 305 degrees. And after that, I will resize the wind tunnel. I set the length of the wind tunnel at 0.884, while the width is at 0.603 and the height is at 0.377. Wind speed I usually vary from 2 meter per second until 20 meter per second, which increment of 2 meter per second. After all the setup is good, I will let the simulation run. During the simulation, I will look into the drag plot. As soon as you click the drag plot, you will see a graph. The blue one is about average drag coefficient, while the white one is about drag coefficient and drag force. I will only take the value when the status achieve stabilize. Usually, the process takes about 10 to 15 minutes to get the simulation stabilized. After I get the value, I will repeat the process for the other two designs. After all the value were taken, we will go to the Matlab and use all the parameters that we get in the Matlab. Okay, this is the last part of the video, which is Matlab part. In In Matlab, I use Simulink to run the simulation. As we can see, there are several blocks that I use to make sure the wind turbine to work properly. So I will go block by block and explain the function of each block. So I will go to the wind speed model first. So in this model, it will produce a random signal of wind speed varied from 1 meter per second until 20 meter per second. Okay, next I will go to the black characteristic block. In the black characteristic block, it will produce a power coefficient and also TSR, which is power coefficient and it is TSR. And after we get the two parameters, we will plot the CP versus TSR graphs to see the performance of the wind turbine. As we all know, CP is how much wind turbine can capture the wind energy and convert it to electrical energy. And after that, we will go to aerodynamic power. In aerodynamic power, we need power and torque. How to get power is from CP times with wind speed to the power of 3 at density and swept area, and we will get power. And how about torque? Torque is we can get from power over omega m. As we all know, power mechanical is torque multiplied by omega m. Next, the torque that we get in aerodynamic power will be used in torque load at the generator. We will use the PMSG as our generator. So in this generator, there are several variables that I use to make sure it works properly. So this is the parameter generator, and all this parameter will load it into the workspace, and after that we will run the simulation to see the result. Okay, this is all the result I got from my simulation by using Matlab Simulink. First of all, let's go to our first graph, which is wind speed. The signal here show it produced randomly from 1 until 20. So it showed that our wind speed produced randomly from 1 meter per second until 20 meter per second. The next graph I want to show you is the CP versus TSR graph. This graph is very important because it will show either our model working properly or not. So by comparing the shape created here and the expected shape, I can say that our model working properly because the both shape is the same. In addition, our wind turbine considered to run at fixed speed. So the signal here show the correct response where the wind turbine run at the fixed speed at 39.5 radian per second. As we can see, even though the wind turbine run at fixed speed, the power produced is keep changing. This can be verified from this graph where the power keep increasing as the wind speed increase. We can refer to these two graphs, wind speed graph and the power graph produced by the turbine. We can see that when the wind speed at 19.43 meter per second, the wind turbine will produce a power of 5.5 515 watt. So from the result here, it verified that this graph is correct. The last graph I want to show you is the power electrical graph. We can see here the value of the power produced here is far more higher compared to the power produced by the wind turbine here. This is because in our system we use a gearbox to change the speed of our wind turbine. So the ratio we use is affect the power generation. So we can see when the wind speed is 19.43 meter per second, the power produced by wind turbine is 5.15, and finally our power electrical will boost up the power to 22.75. As we can see here, our model worked properly well in terms of wind turbine and power generation. That's all from me. Thank you.